Four university friends with various PhDs in polymer science conceive a 3D printing materials company in the Changshu InnoPark. The vision that 3D printing would become a vital production tool was undeniable, and the mission to create higher quality 3D printing materials was tangible. The four friends promised to apply their knowledge and simplify innovation to bring the best quality 3D printing materials to the market. After facing problems with filament jams and failed prints on the popular MakerBot Replicator 2X, jam-free technology was created. This technology raised the softening temperature of PLA from 60 degrees to 140 degrees. OptiPLA was born, a material that could print on any 3D printer without the fear of nozzle jams or clogs. The second product is developed, Max Pla. Applied science and nano-reinforcement technology produce a PLA that's 9 times tougher than regular PLA while still keeping all the inherent printing qualities. Paired with jam-free technology, this material offered high-strength parts that could be produced on desktop printers and allowed engineers worldwide to produce functional prototypes instead of aesthetic models. Polymaker is born. The first logo is designed and their website is launched. Polymaker send 10 300-gram samples to a local reseller in hope of securing their first order. Polymaker get their first customer, 166 spools of OptiPLA in white, black, red, orange, blue, yellow and natural. The team works through the night for 11 days straight to produce the filaments for their first order. Polymaker install their first dedicated production line and develop a flexible 3D printing filament, as the few flexible filaments available at the time had poor compatibility with different 3D printers. Polymaker fine-tuned the plasticity of the thermoplastic to produce a filament that was easy to print while producing soft and flexible printed parts. Polyflex marked the third product to join the growing Polymaker repertoire. Polywood is formulated featuring a stabilized foaming technology that mimics the density of real wood while actually containing no wood particles. Polymaker introduced the first wood filament which prints consistently and offered a unique aesthetic solution with its matte finish. Polymaker display their new technologies at the first 3D printing exhibition in local Shanghai. Polymaker decided to launch a Kickstarter campaign rewarding backers with 3 unique materials in hope of gaining capital to purchase more extrusion lines and grow the business from a startup to a fledgling company. The Kickstarter campaign was a huge success, reaching their campaign goal in just 4 days and eventually raising over 400% of the target, and still remains the most popular 3D printing materials campaign to date. All new materials are delivered to the Kickstarter backers. Word spreads fast about the properties and printability of Max Pla. Polymaker start industrial manufacturing on new extrusion lines. Production capacity quadruples to meet the market demand. Poly Support is developed as a dedicated breakaway support material. By fine-tuning the interlayer adhesion, Poly Support is able to support structures while easily breaking away by hand. Currently, there are very few dual extrusion machines, as the options for dedicated support materials are very thin. With Poly Support on the market, printer manufacturers gain confidence in developing dual extrusion 3D printing. Polymaker received venture capital funding from Legend Star, becoming one of the few venture capital-backed 3D printing companies in China. Polymaker rebrands with a new logo, website, packaging and spool. Polymaker is born, and a new era for high-quality 3D printing materials begins. Polymaker BV is established to tap into the European market. A warehouse and European office are established in the Netherlands. Polymaker PC is introduced, offering a polycarbonate 3D printing material that's compatible on desktop 3D printers. Using Macrolon from Covestro, Polymaker developed an optically clear filament with a low melting temperature, as the current PC options were out of reach for desktop machines. Polymaker PC offered strength, impact resistance, and stiffness unachievable by any other filament at the time. Polymaker's engineers develop a smoothable filament and the first prototypes of a desktop post-processing machine. The filament prints just like PLA and can be smoothed in an easy post-process that removes all layer lines, leaving a smooth, glossy surface. Polymaker BV see rapid growth as they gain resellers in over 15 countries. Polymaker PC sells out in automotive-heavy Germany as more industrial applications are unlocked by the high-strength filament. Production is expanded to meet the growing demand. More extrusion lines are installed and a large warehouse is opened to stock filaments. Polymaker launched their second Kickstarter campaign for Polysmooth and the Polisher, a desktop post-processing machine to remove all layer lines from 3D printed parts and a 3D printed filament that can be easily smoothed with isopropyl alcohol. The campaign was a huge success and the goal was reached in just 4 hours of launching the campaign. Polisher and Polysmooth still remains the most successful Kickstarter campaign for a 3D printing accessory. Polymaker applied their nano reinforcement technology to polycarbonate, producing PC Max. This made the strongest available filament even tougher, boosting impact resistance and retaining a softening temperature of 113 degrees centigrade. PC Max was the first engineering plastic that was available to the masses. Polyplus is used to create the Guinness World Record world's largest 3D printed structure. Reliability was essential when printing on this scale, so Polyplus with jam-free technology proved to be the material of choice. Polycast is launched, offering a new solution for investment metal casting. Completely eliminating any tooling, now 3D printed patterns could be printed and polished before being molded in a ceramic investment. Using ash-free technology, Polymaker developed a plastic with an extremely clean burnout, typically leaving an ash residue of 0.003%. Polycast allowed for quicker iteration on design and was unconstrained by volume or tooling. Polymaker closed their second round investment led by Wanmar Group, allowing for rapid growth and further expansion of production. Polymaker becomes a truly global company, shipping to over 150 countries with 3 worldwide offices. Polymaker Industrial is introduced, offering better material solutions to the growing industrial 3D printing market. Polymaker Industrial expedited research and development of new materials and focused on high-end printing systems. This led to aerospace-grade fire-rated polycarbonates and a wide range of nylon-based materials. 3D printing industry vote Polymaker as Materials Company of the Year in London, UK. The Polybox is launched as a simple solution for storing and printing filaments. New filaments such as Polysmooth and nylon needed protection from humidity, and Polymaker's simple solution guaranteed the optimal printing conditions with full 3D printer compatibility. Polymaker collect the TCT Material Innovation Award for Polycast at the TCT show in Birmingham, UK. Polylite PLA is launched in the US, offering a good quality PLA filament with jam-free technology to the large US-based consumer market. Polymaker launched Polymide Copier, a new copolymer nylon filament with warp-free technology. Polymide Copier displays a very slow crystallization rate, which allows all the internal stresses caused by printing to be released before solidification. This means large nylon parts can be printed with no warping or without the need for a heated chamber. Polymaker developed custom nylon materials for XEV to produce their 3D printed car, the LSEV. This breakthrough project applied 3D printing on a scale that hadn't been witnessed before, largely thanks to Polymaker's research and development of warp-free technology in nylon-based filaments. ABS, PETG, and PC are all added to the Polylite family. This family now offers all the most popular 3D printing materials in the consumer market. With focus on affordability while upholding Polymaker's standard of quality, produce reliable filaments with repeatable results. The third round of investment is secured from Skytrace Capital. Polymaker thrives on expansion and penetrates deeper into the 3D printing materials market. Capacity expansion is also achieved with hundreds of tons of filaments being produced every month. Polymaker redesigned their website, making it easier for online shoppers. The Polymaker portfolio of materials is grouped into product families, allowing further room for expansion while categorizing similar materials. Polymaker developed a glass-reinforced ASA pellet for the Shanghai Construction Group to use on their large format 3D printer. Their first project is a 3D printed pedestrian bridge, taking 30 days to print and weighing in at 5,800 kilograms. Polymaker continued to develop materials for large format 3D printing to aid the technology as it grows. Polymaker launched Polydissolve S1, a water-dissolvable PVA filament that allows for greater freedom of design and a higher quality homogeneous print surface. Nano-reinforcement technology is also applied to PETG, creating Polymax PETG, a mechanically balanced filament with incredible toughness and ease of printing. Polymaker released 5 new colours to add to the Polysmooth range, allowing users to mix, match and polish in a full spectrum of colour. Polymaker add ASA to the Polylight family, providing material solutions for parts that need to stand up to the elements. Polymide PA6CF and Polymide PA6GF also join the Polymide family, combining high strength and stiffness with a high softening temperature, producing extremely hard-wearing 3D printed parts.